Hi, I just wanted to review the graphing quiz we had today. So I'm just going to go through, give you some ideas as to how you can improve, give you some feedback in addition to the written feedback you have received individually on your quizzes. So I just want to go through the first graph here. This is a position graph. Now remember, it's a graph of where you're located. It's really, really important to remember that. So a position graph. So the questions here are pertaining to this. And the other thing to remember for a position graph is when you're thinking about speed or velocity, you're looking at the slope. So the slope is going to indicate any speed, and the changes in slope are indicating changes in motion. So the first thing we're going to do is look at when the mouse changes direction of motion. Well, let's take a look at it. So here my mouse is moving at a nice constant velocity, and then it hits segment B where it begins to slow down and come to a stop. And then after this, it accelerates towards the west up until this point, and then after this point, it gradually comes to a stop again. So when did the mouse change its direction and motion? Well, it was going westward and then it went eastward, so right around here. So we're looking at around 16 to 17 seconds for the actual change in motion to occur. So up until now, we are going eastward and then we began to go westward. So 17 seconds. Now, during what interval was the mouse first slowing to a stop? Well, again, slowing to a stop would be leveling off. I'm first leveling off during segment C. So it's going westward, slowly coming to a stop here with an eastward acceleration, or westward acceleration. So it would be a segment C from 11 seconds to about 16 or 17 seconds. The next question was, during what intervals did the mouse experience a negative or an eastward acceleration? So an eastward acceleration, remember, is negative. So to have an eastward acceleration, we must be accelerating towards the east or moving westward and coming to a stop. Well, here we are constant velocity. Then I was moving and gradually coming to a stop, but I was moving eastward, going towards the east. So this is a westward acceleration. And then I sped up towards the west. So another westward acceleration. It's not until this point here, E, that we have an eastward acceleration. So I was moving west. So you see the slope is up here. And when I'm moving with this slope westward, coming to a stop, it must be eastward acceleration. So it would be E, 24 to 30 seconds. Now the overall displacement was, where did I end up at the end of the day? Well, I started at 10 meters west. I ended up at negative 5 meters west. So I went from here to here, so 5, 10, 15 meters towards the east. So you can write that down as 15 meters east or negative 15 west. Either would be acceptable. Now, for the next part, we did the instantaneous velocity. This is just the velocity at 14 seconds for the curved line. So we have to draw a tangent line. So I've done that over here. And I want to use points that are quite separate here. I want to have a large slope triangle, I call it. So a lot of separation here makes your graph, reading off the graph, much, much more accurate. So this is my first point. This is my second point, so be careful when you're doing this. So my y1 is over here, y2 is here. So y2 minus y1, so it'll be minus 17.5 minus 10. And when we do this, you end up adding 10 to this. So the top becomes negative 7.5 meters. And the x2, 21 minus 0 seconds, so all over 21 seconds, you plug into your calculator, get negative 0.36 meters per second west, or 0.36 meters per second to the east. Either is acceptable. Now remember, because this is a tangent line, there's a little bit of wiggle room when it comes to drawing the tangent. So as a result, your final value here might be off slightly. And that's fine. As long as you're within, I would say, 0.3 to 0.5 in that range, you should be fine. I also just want to point out, make sure you've got units within your slope calculation. At the top, you should have meters. The bottom, I should have seconds. And don't forget your direction again. Some of you forgot to put the direction in your slope. So that's it for the position graph. Now for the velocity graph, you have to switch gears. Now remember, what you're doing here is you're looking at my velocity or speed. I'm actually giving it to you here. So let's look at the motion here. It's going to quickly describe the motion. So for vehicle A, that's this one here, the solid line, we're going from about 40 meters per second up to a stop here. So I'm stopping, 0 velocity, and then I continue with an acceleration towards the negative up to around 15 meters negative, meters per second negative. And I keep a constant velocity for the next little bit here. So again, moving forward, slowly coming to a stop, and from a stop accelerating negatively, and then a constant negative velocity. B started at 30 meters per second, ended up at a stop over here. So the whole time it was slowing down, slowing down with a eastward acceleration from 30 to this. Now, when were the vehicles traveling the same direction? Remember, my 0 line here is the boundary. So anything above this, I'm traveling to the west. Anything that's negative, I'm traveling to the east. So I'm just looking for places where the two graphs are on the same side of the x-axis. And that's going to be between 0 and 4 seconds. So between 0 and 4, even though I'm slowing down, A is still traveling to the west, and B is still traveling to the west. So both of them are traveling westward, 0 to 4 seconds. Next question. At what time was vehicle A motionless? Well, vehicle A motionless is motionless when the velocity is 0, right at 4 seconds. And when did you change direction of motion? When you cross from one side of the axis to the other. So when I cross over right here, so after 4 seconds, I'm now moving eastward. So be careful. Again, this is different than position graphs. You're looking at the velocity or speed. Now let's look for a description of motion now. So vehicle A, and you should tell me, because it's a velocity graph, you should be able to tell me the velocity at the beginning and end of every segment. So for the first 4 seconds, I went from 40 meters per second west to a stop. And I did this with an east or negative acceleration. And then from 4 to about 5.5 seconds here, we went from 0 to minus 15 meters per second. Oops, I made a boo-boo here. Let me just fix that right now. So it should be minus, a moment here, 15. So, or 15 meters per second to the east. So we're accelerating negatively. And then for the remainder here, from 5.5 to 9 seconds, the vehicle maintained a nice uniform velocity of 12.5 meters per second. In other words, its speed was constant. So again, you want to throw some numbers in here, indicate the direction if there's a change in acceleration. So for example, I'm accelerating here to a stop, negative acceleration, then further negative acceleration. And this would be 0 acceleration. So again, just use the description here. Make sure you're giving me some numbers, and you kind of break this motion into chunks, remembering that we're stopping right at 4 seconds. Now, for the acceleration, remember, acceleration is your change in velocity or change in speed over time. So how is my velocity changing? So to do that, all you do is find slope. So what we did is we found the slope between 0 seconds and 6 seconds for vehicle B. So we went from 30 meters per second to 0 meters per second. So this means that this is y2 minus y1. So 0 minus 30 over 6 minus 0 seconds. So I get negative 30 meters per second over 6 seconds. And we get this, negative 5 meters per second west, which means that my velocity is going down by 5 meters per second every single second. That's my change. So you can even see that on the graph for vehicle B. So after 1 second, my velocity went down by 5. The next second, it went down by 5. And this happened all the way down. So another way of writing that would be I'm accelerating 5 meters per second squared towards the east. So again, just be careful just finding the slope or the change in velocity. Now for the area, we're looking for the area up to 4 seconds. So I interpreted this after 4 seconds of ocean. I realize some of you did this area after 4 seconds. That's okay. But I really wanted to do it up until 4 seconds. So what we want to know is how far each of these vehicles traveled. So A is very easy. You're finding the area, and then remember, when you're doing this, you want to take your highlighter, and what you do is you're going to highlight the x-axis and the line. And then you find the area of everything in between here. So in this case, we've got a triangle. So my height of the triangle is 40 meters per second. My width is 4 seconds all over 2, so half base times height. you can end up with 80 meters to the west. So A had a displacement of 80 meters to the west. Now for B, it's a little bit more complicated. You do the same thing. What you want to do is you want to highlight the line only up to 4 seconds and the x-axis. So I have to find the area in between here. So what we do is we're actually going to break this into 2 chunks. The rectangle at the bottom I'll call B1. The triangle at the top we'll call B2. And what we did is for B1, it's very simple. It's simply 10 times 4 seconds. So 10 meters per second times 4 seconds. And you end up with 40 meters. Now for this triangle, it's 1/2. Be careful here. This height is only 20. We're just looking at B2, the rest section here. So 1/2, 20 times 4, or 40 meters. We add them together. So B traveled a total of 80 meters as well. So both of them traveled 80 meters. The question was, how far apart are the vehicles? Well, the difference is 0. They're not apart at all. They're at the same location, or they have the same displacement. So at the end of the day, the difference is 0. Okay, that's it. If you've got any further questions, don't hesitate to come in after school and we'll spend some time reviewing these concepts with you. Take care now.